Hey team, let's take a look at one more example with these KW calculations. So the concentration of a lithium hydroxide solution is 2.56 times 10 to the negative fifth molar. We want to know what is the concentration of hydrogen and is the solution acidic, basic, or neutral? Okay, so there's a little bit of subtext here. Lithium hydroxide is a strong base, which is on your strong base list that you can always have out next to you, which means when it dissolves, lithium hydroxide breaks apart into lithium and hydroxide ions. So when they tell you that this is the concentration of the solution, well, this is also the concentration of hydroxide. Now, with that being said, right, because remember, this for every one of these, I'm getting one hydroxide when it dissolves, so that's why. So, recall our KW formula. 1 times 10 to the negative 14th equals the concentration of hydrogen times the concentration of hydroxide. Well, we know the concentration of hydroxide, so now we can solve for the concentration of hydrogen ions or hydronium. So let's go ahead and plug this into our formula. 1 times 10 to the negative 14th equals the concentration of hydrogen, which is what we're trying to solve for. That's like our variable x, times, well, the concentration of hydroxide is 2.56. Let me do a little erasing so this looks clear. Times 10 to the negative fifth. So again, if I divide both sides by 2.56 times 10 to the negative fifth, we will figure out the concentration of hydrogen. Now I'm going to plug this into my calculator. I cannot stress this enough. When you are plugging this into your calculator, please make sure you use parentheses so that your calculator doesn't mess up the order of operations. Some calculators are smarter than others. Okay, so when I plug this into my calculator, I get 3.90625 e to the negative 10th. And just a friendly reminder, when you see that e in the calculator, it means times 10 to the. And I will make a separate calculator video that might be helpful this unit. Okay, so again, I'm going to look at sig figs. This has 1, 2, 3, so I'm going to round to 3. So I'm going to put not 3.91 times 10 to the, and the answer here is negative 10th. All right, so that is our concentration of hydrogen. How do we figure out if it's acidic, basic, or neutral? We need to compare the concentration of hydrogen to the concentration of hydroxide, right? So think back to this slide. If I have more hydroxide, it's a base. If I have more hydronium, it's an acid. I also have that visual, there's the one I'm looking for, and also this comparison. So let's compare. The concentration of the hydrogen is 3.91 times 10 to the negative 10th versus the concentration of the hydroxide, which was given to us, is 2.56 times 10 to the negative fifth. Now, I'm not going to write it out this time, but 10 to the negative 10th, 10 to the negative fifth, which is larger. Okay, so it's going to be 10 to the negative fifth, right? So that means we have a greater concentration of hydroxide, right? We have more hydroxide ions. And if you have more hydroxide ions, the solution is basic, right? So if we measured this with a pH probe and put it on the pH scale, which we're going to learn about next lecture, we would get a basic result. So hope this helps. Feel free to ask questions on our Zoom.